Hi, everybody. Excuse me. This is the notes for section 5.3. We're going to be talking about angle bisectors obviously, in triangles. So, we have heard this term before. I think it was way back in chapter 1, angle bisector. And really, a bisector is something that cuts something else in half. So an angle bisector is something, a line, ray, segment, or plane, that divides an angle into two congruent adjacent angles. Remember, adjacent angles means they're right next to each other. They share a side. So, gotta go to another screen here. Angle bisectors. All right. So what we have here is triangle ABC. I have constructed this line DB. This one here with where the crosshair is at. That is the angle bisector. You can see that the 32.84 and the 32.84, those two angles are the same, so DB is an angle bisector. No matter how we move the triangle around, those two angles are always equal to each other. So it's an angle bisector. Now, the property of an angle bisector, by moving this thing around, it's not clearly obvious. But if I draw in this segment and this segment, all right, DE and DF, as I move around, you should start to see that those two segments are always looking the same. And in fact, they are. DE 1.91, DF 1.91. No matter where I move these two triangles, those two distances, or move the triangle, these two distances are the same. Now, what are DE and DF? Those are the distances from point D to the sides of the angle. All right? When you measure distance, you always go perpendicular to an object. So we're going from D, point D, perpendicular to AB. We are going from point D perpendicular to side BC. Those are the sides of the angle that got bisected. All right, so we're measuring a distance. So this point D, wherever it is on the angle bisector, it is always the same distance away from the sides of the angle, that is being bisected. Okay, it doesn't matter where we move it, how far away that point is from the angle that's being bisected. That point is always the same distance away from the two sides of the angle. Okay, that's the deal here. That's the angle bisector. So let's go back to the notes. All right. Actually, I'm just going to get rid of that thing. So here is your notes. Go ahead and hit pause. Copy this stuff down. I'll move this. Oops, move that out of the way. These are the two main theorems for this section. Okay. All right. So they're basically the same thing, just one's the converse of the other. The biggest thing, though, is it's an angle bisector. This line AD is an angle bisector. Those two angles are the same. When you go perpendicular here, it forces DB and DC to be the same. And the other way around is if you go from this point D, the same distance to a segment, where you're going perpendicular to those rays there, that point D has to be on the angle bisector. All right, so some examples. Can you conclude that segment or ray BD bisects angle ABC? So looking at this is good. Part number 4 here, the first example. Looking at point D, with the red pen, it shows a little bit better. Looking at point D, we're going perpendicular to the ray BC. We're going perpendicular to ray BA. But do we know point D is the same distance away? We don't know the segments DA and DC are congruent. If they were congruent, then yeah, D would have to be on the angle bisector. So can we conclude that BD bisects angle ABC? Not in this one. Okay, in the middle picture here, Now, this point D, it is the same distance away from those two sides, but are we going perpendicular to those sides? We don't know. So again, we cannot conclude. Now looking at picture 6, is D on the angle bisector? Well, we're going from point D, perpendicular to the side. We have those congruent segments going the same distance and perpendicular to the other side. This is what we're looking for to conclude that ray BD is an angle bisector. Pardon me. All right, so for these examples, we got it right here. This information that says those two angles are congruent. This is an angle bisector. So this point, because we're going perpendicular here and here, those two things are equal. So to solve for x, we do 4x plus 3 equal to 8x minus 9, and we solve for x. And we get x is 3. All right, in this picture, basically, well, it's the same thing, essentially. I didn't mean to have it to be the same example. But again, you got the same, it's an angle bisector because of those two red arcs, which, because we're going perpendicular, makes those two segments equal. So the setup is the same thing. Okay. Sometimes the questions might be, let's turn the question around a little bit. Let's say you didn't know that information there. So the question could be, what are the values of x that would make this point the angle bisector? So if this is going to be an angle bisector, that means those two segments have to be the same. So you would set it up to do those two segments be the same. Then you're solving for x to say, okay, at this x value, these two segments are the same, which makes that the angle bisector. Okay, so you might see that question in the homework. All right, that's it for the main parts of the notes. There is going to be a second video with kind of an application of these angle bisectors. Please watch that one. Bye.